Every weekday, nearly 60 million Americans, 1/5 of the entire population, spend 8 hours trapped inside what some experts consider the germiest buildings in America. Trapped inside these buildings with them are millions of invisible enemies seeking to make them ill or sometimes even kill them. We're talking about diseases such as staph, E. coli, Shigella, influenza, MRSA, and mold. These denizens of the invisible world are all around us, on flat surfaces and chair backs, on computer keyboards and mice, door handles and sink handles. Where do you find all these hidden killers? Where is the germiest building in America? It's a public school. And while the situation is bad enough when we consider middle schools and high schools, it's an even bigger issue in elementary schools. Young children do not have fully developed immune systems. They're known in the medical industry as immunocompromised. Yet every day we expose them to bacteria and viruses and mold spores. What can be done about it? Typically, there are two responses. We can teach kids better hygiene practices like hand washing and bathing so they don't bring germs with them. And when they do get exposed, school nurses and doctors are there to help them deal with headaches and nausea. But what can we do about the germs that do get into our schools and onto our surfaces, waiting patiently for days, weeks, even months for unsuspecting hands and pencils and backpacks? There is only one professional that can do anything about getting rid of the germs that have infected our buildings: the school custodian. Custodians should be the first line of defense against pathogens in the schools. Unfortunately, most janitors today are not trained or equipped to deal with this invisible world. They do not understand the spread of disease or how to break the infection cycle. And they're armed with antiquated tools, mops and buckets, rags and spray bottles that don't actually attack bacteria. In fact, they spread it around, becoming disseminators that carry disease from surface to surface, classroom to classroom. According to Dr. Charles Gerba of the University of Arizona, mops and rags give germs a free ride. You can actually make things worse if you are not cleaning properly. So the next time you visit your child's school, or if you're a teacher the next time you walk into a classroom, don't just look around and ask if the room looks clean. Ask yourself, is it hygienically clean? Most likely, the answer is no. Then you may want to ask the principal or superintendent or PTA if your custodial staff has received the tools and training they need to make this building safe for the children. Again, the answer is almost certainly no. And if this is the case in your school, you need to ask another question. Why isn't the district doing something about this? Doing what is necessary to protect our children, the teachers, and the staff from the germiest buildings in America? Typically, there are two answers to this question. The first is budget. Most districts are struggling with budget reductions. They're trying to figure out how to divide the dollars they have and rarely allocate enough money for the custodial staff and equipment that are necessary. In fact, many school districts have cut their cleaning budgets by 25% or more over the last 10 years. Why would they do this? That brings us to our second reason: knowledge. If your administrators are like others in the country, they don't have the knowledge they need regarding cleaning science. They don't understand that school bathrooms are really biohazard waste transfer stations that can breed disease. They don't recognize that locker rooms and athletic mats are key sources for MRSA, or know what to do about it. They're unaware that flat surfaces in classrooms and cafeterias become traps for dangerous pathogens. They don't appreciate the importance of critical touch points like computer keyboards or mice, where norovirus or flu bugs can pass from student to student. And school administrators are unaware of how recent advancements in cleaning science have led to the introduction of hygienic cleaning, new processes that specifically address the invisible world. There are now no-touch cleaning systems that attack the biohazardous waste in restrooms and locker rooms. There are technologies specifically designed to clean flat surfaces because research showed that properly cleaning desktops can reduce student illness and absenteeism by 50%. And there are low-cost disposable wipes for cleaning critical touch points and minimizing disease transfer. And finally, one of the most important advancements is the new ATP meter, which accurately measures biopollution and makes the invisible world visible. Surprisingly, all of these hygienic cleaning solutions have come from one company dedicated to using science to enhance life.
Yet the greatest threat to survival is so small that it's invisible to the naked eye. an enemy that is relentless and even changes its tactics, even its very form. There's a definite connection between human health and soil removal, and it's clear that most restrooms today pose a very real threat to building occupants.
The restroom is probably the most dangerous area in a public building. In reality, it's a biohazardous waste transfer station. More bluntly, it's the place where biological waste is transferred from the human digestive tract to the sanitary sewer system. Unfortunately, this transfer is not always sanitary or effective. Too often, there are accidents, spills, drips of urine, feces, vomit, blood, and other bodily fluids. Plus, every flush of the toilet creates an aerosol of potentially biohazardous particles, including E. coli, Shigella, and other fecal toxins. This phenomena, which is sometimes referred to as the toilet sneeze, broadcasts aerosolized particles into the air which eventually settle on the surrounding surfaces, including walls, dispensers, and even the floor. By far, the most plentiful biopollutant in the restroom is urine, typically concentrated around urinals and toilets. This normally sterile urine becomes a very rich food source for odor and disease-causing bacteria, in particular E. coli. This is probably why studies show that floors have the highest counts of E. coli of all surfaces in the restroom. So, how do these harmful microbes make us sick? Well, they first must find their way into our bodies. This is commonly accomplished through the fecal-oral transfer, literally hands to mouth, nose, and eyes. Hands can be contaminated by coming in contact with static transfer points, such as dispensers, faucets, door handles, even desktops. In addition, any object that comes in contact with a contaminated surface becomes a disease transfer point and is referred to as a fomite. The most practical defense we have against these invisible microbes is effective cleaning and proper hygiene. With all the problems in the public restroom, it's important that we go beyond simply cleaning for appearance to cleaning for health.
The vast majority of restrooms today are cleaned with a traditional string mop. However, there are some inherent problems with mopping, problems that can compromise health. First, to save time and reduce slip-fall accidents, most restrooms are damp mopped, which typically involves a single pass with a very small amount of cleaning solution. This thin film of solution is insufficient to remove, emulsify, or disinfect the soils on the floor. Besides, as soon as the dirty mop is wrung or dipped into the bucket, the solution becomes contaminated. So essentially, the floor is being cleaned with contaminated solution that is simply spreading around. On a tiled floor, the issue is even more complicated. Because of the rough surface texture of grout, mops just can't pull matter out of the grout line effectively. Soils and biopollutants that have been absorbed by the porous grout have little chance of ever being removed. Plus, during mopping, the grout line actually squeegees the soils and soap scum from the mop's fibers. This is why even newly constructed restrooms often exhibit the telltale symptoms of decline and chronic contamination, like stained, darkened grout lines and obnoxious odors. In fact, lingering stubborn odors are actually evidence of ongoing bacterial activity.
The good news is that dangerous biopollutants are relatively easy to remove and dispose of properly with the right cleaning technique. One such method is no-touch cleaning from Kaivac.
Designed to remove the maximum amount of unwanted matter, a no-touch cleaning system combines automatic chemical metering and injection, an indoor pressure washer, and a powerful wet vacuum into a single integrated system. Its ultimate purpose is to decontaminate the biohazardous waste transfer station. To begin, the operator applies automatically diluted cleaning solution to fixtures and floors in a low-pressure fan spray. As the liquid cleaning solution dwells, it loosens and lifts soils in preparation for vacuum extraction. In addition, the fluid brings residual dehydrated soils, such as dried urine, into liquid solution. Next, the operator pressure rinses the target surfaces with fresh water, power rinsing hard-to-reach areas such as seat hinges, behind toilets, and so on, carrying contaminants to the floor in a current of water. The power of the indoor pressure washer is ideal for attacking accumulated matter without harming surfaces or personnel. If necessary, the operator can manually brush problem spots to further loosen soils. Then, the operator suctions all liquids and contaminants from the floor with the built-in wet vacuum. This high-flow fluid extraction process creates a liquid current that transports the unwanted matter into a recovery tank where it's contained and quarantined. The vacuum also leaves the floor clean and dry and ready for use. The drying action also inhibits bacterial growth. Kivac's goal is to deliver cost-effective, worker-friendly cleaning systems that protect the health and safety of a building's occupants as well as the environment. As a result, we design our no-touch cleaning systems from the start for deep cleaning in a way that's extremely efficient yet environmentally responsible. We take a holistic approach to green cleaning. Not only do we incorporate environmentally friendly products and methods, but just as important, we remove the maximum amount of indoor pollutants. Recent studies confirm that all cleaning methods do not produce the same results. A comparison was made between traditional mops, flat mops, and the Kivac no-touch cleaning process, measuring soil and bacterial removal in grout lines. The results showed that traditional and flat mops left 35 times, that's 3,500% more soil and bacteria behind than no-touch cleaning.
Considering the definite connection between human health and soil removal, it's really important that these areas be cleaned completely and properly to remove the harmful biological hazards and to reduce the risk of disease.
Do you want to find out how effective your cleaning program is? Start measuring. Measurement technologies are now available that can help you instantly quantify the effectiveness of your cleaning program. For example, handheld ATP meters rapidly measure the amount of biopollutants on virtually any surface, including floors, sink handles, toilets, dispensers, desktops, and so on. The easy-to-use palm-sized devices specifically detect and quantify the level of adenosine triphosphate, or ATP, the universal energy molecule found in all animal, plant, bacteria, yeast, and mold cells. These innovative instruments are commonly used in a number of other industries, including healthcare and food processing, to ensure health through proper sanitation. With ATP monitoring, it's now possible to establish a quantifiable standard of hygiene that defines when a surface is really clean for different areas throughout your building. The self-dispensing design and variable spigot on the KaiMotion Flex makes it ideal for fast, hygienic wet mopping of classrooms. Not only is this method faster than using a traditional mop, it produces a cleaner, healthier result. And you use a fresh pad for each classroom, which greatly reduces the risk of transferring soils from room to room. Before we begin, it's important to note that we don't use pre-soaked microfiber pads to mop the room. Instead, we'll use a dry pad and moisten it with diluted cleaning solution that's been dispensed through the spigot at the rear of the trolley bucket. The reason we do this is that a pre-wetted pad will only get about a quarter or a third of the way through the classroom before it dries out, which means you'll use 3 or 4 pads to clean the room. Also, the layout of the room will determine how you approach the mopping process. For example, if the room is congested, with too many desks or other obstacles, you'll want to lay a bead of fresh cleaning solution along the back wall. Then, as you mop, you'll pull the solution from the back of the room down into the aisleway. If you're fortunate enough to have wider aisleways and room at the front and back of the rows, you can serpentine your way through the classroom, dispensing the cleaning solution along the way. This is the preferred approach whenever possible, as it's quicker and easier to mop under and around the desks. Let's see how the process works in a congested room. Wheel the KaiMotion Flex system to the far end of the room. Now, to dispense the liquid, open the spigot and walk in a straight line along the rear of the room, starting at the far end and moving back towards the entrance. The wider you open the spigot, the greater the flow of liquid. You'll want to lay a bead that's 6 to 8 inches wide. Adjust your walking pace and spigot flow to get the right bead width. Don't forget to close the spigot when you're finished laying the bead. Next, we'll attach a microfiber wet mopping pad to the pad frame. Even though we start out with a dry pad, we'll use one that has been manufactured specifically for wet mopping. In our case, we use a blue rim pad to denote a wet mopping pad, which is easy to see through the semi-transparent bins. The pads are stored face down in the bin, which makes it very easy to attach them to the mop frame. Now, begin with the farthest row and mop towards the front, dragging liquid from the bead. As you return to the back and begin a new row, you can re-wet your mop head in the bead. Continue this process until all the rows have been mopped. When you're finished, simply fold and peel the dirty mop pad into the bin reserved for soiled pads so that it can be laundered and used again. Folding and peeling the pad helps avoid touching the soiled face of the pad. In a less crowded classroom, we'll use a serpentine method to apply the liquid bead. For this process, again, begin at the far row. Now, open the spigot and walk the aisles in a serpentine manner, laying out a 6-inch or so bead. You'll work your way back to the entrance where you'll park the Flex unit. Return to the first row and begin mopping, basically following the path you took when dispensing the solution. Since the pads never enter the solution tank, the solution remains fresh for more effective cleaning and fewer trips to the janitor's closet. The design of the ergo handle and mop pads makes maneuvering in tight spaces simple and effective. The microfiber flat mop heads lift more soils than traditional mops, and they don't have those strands that tend to get tangled up on desk legs, chairs, or table legs. The pads also have a greater surface for cleaning. Another benefit of using flat microfiber mops is that you use less solution, thus less chemical, saving money. Also, putting less chemical onto a finished floor may actually help extend the life of your floor finish, as well as reduce residual chemical film and vapors. Once you've finished mopping the room, simply fold, peel, and remove the mop pad into a Flex bin with soiled pads, and they're ready for laundering. On days the room is not being wet mopped, there may be a need to spot mop soiled areas. To do this, simply attach a wet mop pad to the pad frame and dispense a small amount of cleaning solution onto the floor. Dip your mop pad into the solution and spot mop as needed. You're now ready to move on to your next room.
Introducing KaiFly, the innovative patent-pending system for high-volume, flat-surface cleaning with zero cross-contamination. KaiFly combines microfiber, window squeegee, and chemical injection technologies to rapidly remove harmful biopollutants from desktops, tabletops, stalls, partitions, or virtually any flat surface. In fact, KaiFly is scientifically proven through bacterial testing to remove 80 times more bacteria than microfiber towels or rags, making it an ideal process for reducing the risk of MRSA, norovirus, and other contaminants living on desktops. Conventional cleaning tools, like towels or rags, have been proven to disseminate bacteria across surfaces. This cross-contamination can leave the last surface cleaned with 2 to 8 times more soil than the first surface cleaned. KaiFly eliminates the risk of cross-contamination, maintaining equal effectiveness regardless of the number of surfaces cleaned. And, with its ergonomic design, Ki-Fly cleans in half the time of traditional methods, with less strain on workers' backs and shoulders. The worker simply applies cleaning solution to the target surface with the microfiber pad, then squeegees the surface to simultaneously remove contaminants and dry the surface.